So next we are going to see about how IIoT through this visual webinar is working. So this is a particular website, Edge Impulse, so which has embedded machine learning inside it to detect the anomaly detection what we feed from the IoT devices. From the IoT, we are collecting the data and going to give it to the particular this site so that this site will works based on the machine learning algorithm. That algorithm will detect the anomaly in my machines in real time. So already having the account, so I'm just logging in this Edge Impulse site. So after deleting all my old projects, I'm going to start from this is the new window which you're going to visualize when you log into the Edge Impulse site. So site is mainly used for IoT data analytics. So just to create a new project with a new name, Surya IoT data analytics. So the project is just created now. So this is my project title, and there is this is the actual dashboard of how it will be looking like. On the left side, you will be having the dashboard and devices, data acquisition, and impulse design and retrain the model, live classification, model testing, and deployment into the final hardware. So we are going to start with the devices. So here we don't have actual microcontroller. So I'm going to use my mobile phone as my controller, which is going to feed the data to this particular site. So connect with the new device, this button. So there are different options are available. You can load the data already from particular server, and also you can load by mobile phone, and also certain development board also supported. So here I'm going to use with my mobile phone. So now I'm going to scan my mobile phone. So with this QR code. So my mobile phone has scanned the particular QR code. Here, the data collecting agent has been created. The client has been created. So now my device is connected to this particular site. So this is my devices. The what sensor it is being connected is indicated over here. That is the accelerometer and microphone. So next, I have to accuse my data. I have to collect my data from my mobile phone. So I have to select what data I'm going to collect. The sensor, microphone, and camera. The accelerometer will produce a more number of data. So I'm going to select the accelerometer, and you can select the frequency rate and also the sample length in terms of milliseconds. So that within a 1 second, I'm going to get 1,000 different data. Start sampling. So I'm going to label it as accelerometer. So start sampling. Once I start sampling in my mobile phone, it will be indicated as the record is being created. So I'm just given a sudden impulse in my mobile phone, and then again I'm going to rotate my mobile phone. So let's see how the data is being collected for 10 seconds in this platform. So this is how my data is being collected for the particular 10 second. So in the impulse tab, I'm going to do what are the process I'm going to do. So I'm going to use my raw data and add it over here, and the learning block I'm going to use the k-means anomaly detection. I'm just going to create a save impulse, and I'm going to see how my raw data is being created. So this is the window size. This is called as a Hamming window. What you actually studied in DSP. So which part of the variation you are going to feed as a anomaly, so it will be created over here. You can increase and reduce the size of this Hamming window from this create impulse tab. So I want to reduce my, so that I want to see the minute variation of my actual raw data. Here my Hamming window size will be getting varied, and this I'm going to make my system to learn this is actually where the anomaly is being created. So again, so once I select the disturbance in my system, I'm going to save my parameter indicating this is my anomaly. So once this it's been saved, I'm going to create the features. So it will create a 3D map of my design. Here I'm generating my features. So once it is being completed, it would create a message, generate a message called job completed. So here, if I take a data from multiple mobile phone, multiple devices, there are a lot of visualization layer will be created over here. So in the anomaly detection, we have created a feature map. From the different feature value, there are a lot of value has been created. Feature value has been created for my mobile phone for this particular 10-second data. I'm going to train my data with the anomaly which I have selected. So after getting training, I'm going to retrain my model just. So it is having a lot of machine learning package. We have used a k-means anomaly detection. So it is training my data, what I have been fed. So this is actually a single machine data. That is my single mobile phone data. We can take the data from number of mobile phones and users. That is means the different sensors of a same. For example, in a factory, we are having the 100 machine running with the same sensor, temperature sensor. The temperature sensor data which is fed into this particular cloud, and we can train which is the anomaly actually, and we can go for the live classification now, whether my training is properly done, whether the system can able to identify again where the anomaly is. So I have to select the devices. Here my device is getting disconnected. So again I'm going to connect to my site. Again my device is getting connected. I'm going for the live classification. Now here the device is selected. Again it is for 10 seconds and the same frequency rate. I'm going to take the sampling. Now I'm going to take a Q. I have feeded the data. So now let's see how my data resembles. So now I voluntarily make it different. See my, this is actually faded data, and you see that where are the anomalies and where are the good signal has been available. So this is the live classification or different anomaly detection. You can do certain research obtaining from the real-time parameter, and you can directly deploy this to the any of your hardware devices. So IoT analytics